Swayam Prabha. Digital India. Educated India.
So students, in yesterday's class, we have discussed the Geosm-Natec framework. And today I will show you one example so that you can see through this demonstration how to apply this Geosm-Natec frame. So today we will be discussing the Geosm-Natec framework, its application for urban floods. I will also bring up particular reference to a project ENACT evaluating the feasibility and efficacy of integrated catchment scale nature-based solutions for climate change adaptation in India. It was done for the Guwahati city and it was a multi-institutional project, and we took care of this nature-based solution where we use the Geosm-Natec framework. In that, we will be discussing risk, the identification and prioritizing, then geospatial data acquisition, geospatial map development, analysis and hotspots, and strategic planning with community. And today we will end with the summary for the lecture module 8. So 8th week and those lectures we will be discussing in summary. So Geosm-Natec framework and its application for urban flood. I will start with some recap on the previous lecture, that is Geosm-Natec framework. Conceptual methodology, as we have discussed, that this framework helps us in risk hotspot identification and potential solution space identification. It advocates preservation of areas with pre-existing healthy ecosystems. It advocates restoration of areas that are showing signs of degradation and revival of areas that are under threat. This framework, Geosm-Natec, it is actually taking help of the remote sensing and GIS. So it is using all the advanced technologies. Remote sensing and GIS is helping in mapping topographical and geographical features of urban settlements, and Geosm-Natec framework maps both natural as well as the man-made influencing factors responsible for urban flood. Remote sensing helps in mapping very categorically meteorological parameters such as rainfall, temperature, RH, risk zone considering urban parameters or features responsible for urban risk, in this case it's flood, urban natural and man-made catchment delineation, streams network delineation, rate of urbanization delineation and change in LULC, runoff or discharge quantification, and probable site for inundation zone delineation. So, in yesterday's class also we discussed this particular table for urban flood. The urban risk hotspot mapping, the risk is the flood, urban flood. Hazard map, we discussed the flood volume, run-up depth and the precipitation. Exposure map, NDBI, population density, critical infrastructure mapping or geotagging also. Land use land cover, urban hydrology and land use topology. Under the vulnerability map, NDVI, NDWI, soil hydrology, urban hydrology, social and economic, socio-economic status that has been captured. So, any Geosm-Natec framework, if you have to apply, you have to have these information with you. So, as I mentioned this particular ENACT project, I will show that for Guwahati city how we have worked. So, this is a map of India and you can see the Guwahati here, Kamrup district boundary, and it's the Guwahati. And this is the master plan boundary of the Guwahati city. And this is the study area of interest. This particular city is always having the issue with the pluvial flood. But recently it is also now reporting the urban flooding as well. So, identification and prioritizing under this, the historical inventory of urban flood in Guwahati that was recorded. Urban flood in Guwahati as per the record of local SDMA It happened in 2001 and then in 2010. Water bodies like Dipor, then the rivers like Bahini Bharalu River, Bashishta River, they have become sewer channels and dead rivers, which has contributed towards an increased incidence of urban flooding in the city. 5 kilometers away from the Rukmini Nagar, Zoo Narengi Road in the city is notorious for frequent flooding. I'll be showing some of these locations in next slides. The central part of the city has small hillocks, namely Sarania Hill, Navagroho Hill, and Nilanchal Hill, and Chunsali Hills. The Buragosai Parbat in the east and the hills of Rani and Garbhanga in the south form the major hill formations of the city. And many of the local people, especially the aged one, they were actually complaining that many small hillocks are actually vanishing under the pressure of the urbanization. Historical inventory, if we continue, then we can see the sediment yield and high runoff generation from the hilly terrain of Guwahati city is one of the important factors responsible for urban flooding of Guwahati city. It has 5 broad natural drainage basins. These includes Varalu Basin, catchment area of 100 square kilometer, Silsako Bill Basin, 92 square kilometer, Dipor Bill, 144, one of the largest basin, Kalmoni Basin, 66 plus square kilometer, and Foreshore Basin. The government has identified 39 locations within the city that are urban flood prone, like Hatigao and Chandmari. Now you can see Hatigao, you can see Chandmari, Chunsali Hills, Zoo Narengi Road I was mentioning, Varalu River, Bashishta, Diporbil, Navagraha Hills here, Nilachal Hills. So you can read it, and these are the geotagged locations. All of them have been geotagged. And the geospatial data was acquired using different sensors, Landsat, Spot, IRS, Iconos, all. Resolution has been mentioned here, spectral ranges, and the revolution interval in days have been mentioned here. So you can read this table, which has been part of the geospatial data. And the data was acquired from USGS Earth Explorer, Planet Database, MODIS data, NASA Earth data, Bhuvan platform, and the NICES. Image analysis, as already we have discussed yesterday, NDVI, NDBI, and NDWI, and we have discussed these mathematical equations as well. And the features it delineates, that also we discussed, like vegetation, its density, area, health, typology. NDBI talks about built-up area, spatial density, area and pattern, and NDWI water, the area and shape. Mapping of each geospatial layers on the GIS platform happened based on this NDVI and BI and WI info. Geospatial map development, you can see that NDVI, NDBI and NDWI here. And for this 2022 data, we can see here it was developed. And then hydrological parameters like stream networks, you can see the stream networks here, stream order, you can see the stream orders here, and watershed basins for delineating the catchments. The basins have been delineated here. So this particular stage had been carried off. Then the data, this rainfall data was collected, rainfall map and runoff map was created. This is the runoff map and this is the rainfall map. And there is 3 stations. This IWD interpolation was done based on the data collected from these 3 stations. And again, I am bringing back those base layers which we have discussed, NDVI, NDBI and NDWI, and then the stream orders, and then the stream network and the basins. And now you can see here the soil map was created, LULC map, the change, land use land cover change map was created, then the rainfall pattern was created and the runoff map was created. So these many layers have been created, and based on this creation, this particular urban flood hotspot zones were identified through the overlaying technique, and I also discussed with conditional linkage interconnection. That logic was applied, and then this particular map was created, where this actually gives us the idea that feature having more potential for urban flooding. So based on these information and the ground truthing, these 220, 160 and 104, these are the specially three areas. One was Anil Nagar, one was Kalapahar and one was Lokhra, which we had actually identified to do the study in depth. So run-up map was created and the discharge was calculated with the formula of runoff and the area of the grid. So you can see that Anil Nagar and the Kalapahar and this Lokhra, and they come from this particular overlaid map only, hotspots, and the land use land cover for these three, that resolution, final resolution study was made, and you can see that ultimately the discharge was calculated, that flow direction, stream order and the discharge. So that was from Anil Nagar, the first one, and then it is Kalapahar, the middle one, and the flow direction is on the east, and stream order 4 and discharge is 20,000 plus cubic meters. Similarly for Lokhra also. Lokhra we have taken with a very special interest because we had our colleague there who can do the community survey as well. So Lokhra, though it was not showing very high potential risk, but then also it was having a potential, and we had gone for this one, and it is also having very high discharge we could find. Then community engagement we had done there through the workshops, and the colleague could get the architectural model of that area, and that was actually used as a tool for communication with the community. So we had also created the morphology map for this Lokhra hotspot and infrastructure map for the particular area, same area, and base layer identified urban flood hotspot zone and hotspots flow direction and land use land cover. That was our stages followed. And this particular interaction, community interaction, actually highlighted many such issues which we would not really understand at the very first instance. While going through the ground truthing, we could actually understand the validity of the different concern raised, and we could also validate our own model through this process. And this is the blue-green infrastructure basket which we had created. The components like a bioretention cell, vegetated soils and green roofs, permeable pavements. This was created, this was shared there as well, and we could pick up some of the strategies for the modeling. So once the modeling was done, and then we have tried to look at how this bioretention cell physically can come there. We had overlaid this information on a image from Maxa, and on that we have tried to look at how these strategies can look like at that local scale. So this is the way the strategic planning we had proposed in that particular ENACT project, which is based on not only Geosm-Natec, but also Geosm-Natec is having a very strong community partnership, and there we have talked about it. So as yesterday we have discussed in this Geosm-Natec framework, first we try to understand the area, study area, and the problem itself try to understood from the literature and the survey. Earth observational data, which I have shown you just now, and the overlaying of them, identifying the potential zones where we can go for potential zones for both the hotspots, the risk hotspot, as well as the implementation, and checking the efficacy. Checking the efficacy of this, we have actually deployed two strategies, one with the stakeholders, the community, and one with the modeling, SWMM modeling. Then we have picked up the NBA strategies, and then we have identified that how that strategy can go on the spatial scale. And if it gets implemented, we can again relook at this cycle. That's the way Geosm-Natec framework works. So that's the way we conclude the Geosm-Natec framework concept discussion as well as the application case, and we'll be now concluding the module. We will go for a recap of this module 8 to conclude today's lecture. And the module 8 was on mitigation and adaptation. And the first lecture of this 8th week was disaster risk and climate change. Key concept we discussed, that is disaster risk, is the convergence of hazard, exposure and vulnerability, and this is intensified by risk drivers like climate change. Hazards are potentially damaging physical events categorized into natural, anthropogenic and socio-natural types. Vulnerability encompasses physical, social, economic and environmental factors that increase susceptibility to hazard impacts. The UNDRR framework shifts focus from post-disaster response to pre-disaster risk reduction and management. The keywords for this lecture was disaster risk, hazard exposure, vulnerability, coping capacity and climate change. In the next lecture, lecture 37, we discuss mitigation and adaptation. Resilience requires both mitigation, reducing causes like emissions, and adaptation, adjusting to impacts. Mitigation strategies include structural measures like seawalls and non-structural measures like land use zoning. Adaptation strategies range from reactive coping mechanisms to transformative changes in infrastructure and behavior. Resilience is defined as the system's capacity to absorb shocks, recover, and adapt to long-term changes and uncertainty. Keywords are mitigation, adaptation, resilience, structural measures, transformative adaptation. And next lecture was on transformative solutions, nature-based solution basics we introduced here. Nature-based solutions protect and restore ecosystems to address societal challenge while providing human and biodiversity benefits. Transformative solutions fundamentally shift underlying systems, policies, infrastructure, rather than just treating symptoms. Natural capital, forest, water, soil, is the essential asset base that sustains economic flows and ecosystem services. Global bodies like IUCN and IPCC promote NBS to achieve co-benefits like climate regulation, food security, and disaster risk reduction. Nature-based solutions, natural capital, transformative solutions, IUCN, and co-benefits, they were the keywords for this lecture, lecture 38. Lecture 39, the title was Nature-based Solution for Climate Adaptation and Urban Resilience. The key concept we discussed: as the global mitigation window closes, adaptation becomes an emergency response to address long-term environmental risks. NBS mechanisms mitigate specific risks such as reducing the UHI effect via evapotranspiration and managing floods via infiltration. So, multi-benefits. Social equity challenges include preventing green gentrification, where ecological improvements inadvertently displace vulnerable populations. Planners must manage ecological disservices like allergic pollen, VVOC emissions, and the vector-borne diseases alongside the benefits. We discussed adaptation gap, bounce forward, green gentrification, ecological disservices, and evapotranspiration in this lecture. And the concluding lecture of this 8th week was ecosystem-based adaptation and EcoDRR. Key concept discussed is the EBA and EcoDRR, which utilize biodiversity and ecosystem services to help communities adapt to climate change and reduce disaster risks. EcoDRR sustainably manages ecosystems to mitigate hazards like floods and landslides. Green versus grey debates were raised, such as in Kerala's coastal erosion crisis, highlight the conflict between hard engineering and nature-based approaches. Bioengineering stabilizes slopes using living vegetation like vetiver grass, offering a resilient alternative to rigid concrete structures. Keywords for this lecture was ecosystem-based adaptation, eco-dearer, coastal resilience, bioengineering, green versus grey. So we have discussed the application of Geosm-Natec framework, and we have also discussed the recap of module 8 in this particular one, and with a particular case application, Geosm-Natec application has been elaborated. And thus we are having the 59th lecture today completed, and tomorrow we will finish the last lecture of this course. So this is the list of references for you. Thank you.